Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. Okay, lesson 7, secant and the cofunctions. Classwork opening exercise. Find the length of each segment below in terms of the value of a trigonometric function. Okay, so in terms of the value of a trig function. So the only distance we can find from here is OS is 1, OP is 1, but without knowing theta, I don't know the length of PQ, I don't know the length of OQ, I don't know the length of RS. So in terms of trig functions, we can answer these with respect to theta. So OQ is the adjacent side to the angle theta, so that is cosine theta. PQ is opposite theta, so that is sine theta. And RS, now be careful here, RS is out here. What is RS? Well, this point R is the point over 1 up a distance of m. So this point right here is a length m. So we went over 1 up a length of m, which we don't know. So it's 1 comma m. And this is cosine and this is sine. So RS is m. The length of RS equals m. But that is not a trigonometric function. But m over m equals m over 1. And if I put m over 1, I'm putting sine theta over cosine theta, and that is tangent theta. So RS is the tangent of theta. All right, example 1 says to use similar triangles to find the value of secant theta in terms of one of the other trig functions. Well, what is secant theta? Do we know? Let's find out. Okay, so let's start with secant. Let me go back to my pen. The secant function description. The secant function. Secant is the set of all x such that they're real. The set of all x in R such that x equals or does not equal 90 plus 180k. Well, let's just put 0 in for k. 180 goes bye-bye, and 90 is right here. If I plug in a 1 for k, 90 plus 180 is 270. That is right there. If I plug a 3 in for 180, 180 times 3, or actually 2, 180 times 2 is 360 plus 90. So here would be a 360 rotation plus 90 puts us back here. So in other words, when I'm at the point 0, 1 or 0, negative 1, x cannot be there. We cannot let x equal 1 or negative 1. And the only way we get that is when k is when the value lands at 90 or 270 degrees. Okay? So let theta be any real number such that theta does not equal that 90 plus 180k for all integers k in the Cartesian plane. Rotate the initial ray by theta degrees about the origin. Intersect the resulting terminal ray with the unit circle to get a point x comma y, or x sub theta, y sub theta. The value of secant theta is 1 over x sub theta. So remember, if I choose a point x comma y like this, the point x comma y is also cosine of theta comma the sine of theta. Cosine is your x value, sine is your y value. So if I take the cosine theta, which is x sub theta, and say 1 over x sub theta, what I'm really saying is 1 over cosine theta, and that's secant. And cosine is, well, the way I should put this is secant theta, by definition right here, The value of secant theta is 1 over cosine theta, and 1 over cosine theta is 1 over my x sub theta. Okay? And it just so happens that cosine of theta equals x sub theta. So 1 over x sub theta is the inverse of x sub theta, and therefore secant is the inverse of cosine. Okay? Cosecant says that it is the set of all x, and we call it CSC for short, cosecant, cosecant. X is in the set of reals such that x cannot equal 180k for all integers k. So there's no 90 plus here. So if I make k 0, I'm right here. And if I make k 1, 180 is right here. If I make k 2, I'm at 360 here. If I make k 3, I'm at 360 plus 180, 540, which is here. So I'm just bouncing back and forth. So in other words, cosecant theta cannot be at the point 1, 0 or negative 1, 0. And the reason being is my y cannot be 0 or be undefined. So just like here, I will say cosecant theta, I should have a theta here, by the way. Cosecant theta equals 1 over y theta, which is what we were given, and sine theta is y sub theta. So the sine is your y value, okay? So cosecant, since cosecant is 1 over y theta and sine theta is y theta, then cosecant function is the inverse of sine. Okay? Cotangent. Cotangent is a set of all x values in the set of reals such that x cannot equal 180k for all integers k. So notice it's got the same restriction on the domain as the cosecant does because it is x theta over y theta. So if cotangent equals x theta over y sub theta, well, x sub theta over y sub theta is cosine theta over sine theta, isn't it? Okay. And tangent is the other way around. Tangent is the inverse. Tangent of theta, I should have theta here. Tangent of theta equals sine theta over cosine theta. But what is our sine theta? Sine theta is y theta over x sub theta. So if tan theta is y over x and cotangent's x over y, then cotangent is the inverse of tangent. Okay? So there are the three definitions of our cofunctions: cosine, cosecant. I'm sorry, cosine, secant, cosecant, sine, cotangent, tangent. And one way to, cotan and tan are pretty easy. You can't mix those two up. The two that get mixed up are cosecant and secant. How do we remember that? Well, just think of it this way. Cosine backwards would be C-S-O-C. So the only difference is the E in the middle. So if you take the C and the S and flip them and get S and the C, cosine, secant are inverses. One way to try to remember that. Okay, example 1 says to use similar triangles to find the value of secant theta. All right, so we want to find the value of secant theta in terms of one other trigonometric function. All right, so it said using similar triangles as well. So I've recopied these down. So it's broken out of this diagram. So OPQ is the red triangle and ORS is the black triangle. And they're similar because they share theta, the angle of reference, the central angle, And then they have 90-degree angles here. So since we have angle-angle similarity, we know these two triangles are similar, so we can set up a proportion. So what I'm going to do is I'm going to separate these two, like so, to explain this. So OS is adjacent to theta. RS is opposite, and this is the hypotenuse. Okay? Similarly, OQ is adjacent. PQ is opposite, and OP is the hypotenuse. So we can set up a proportion, which is comparing two ratios, setting them equal to each other. All right, so we're trying to find the value of secant. So in order to do this, what I'm going to do is take the original, or the larger triangle, I mean, and put OS over OR. And with respect to OS over OR, what is that with respect to the theta? Well, OS is adjacent, and OR is the hypotenuse. Okay, well, what is adjacent over hypotenuse? That is the cosine of theta. Okay, so OS over OR is cosine theta. So we're just going to do that first, and then we're also going to do the same down below, and we're going to take OQ. Let me do it in red. We're going to take OQ and divide it by OP. Okay, and what is that? Well, OQ is adjacent, and OP is the hypotenuse. And adjacent over hypotenuse, again, is cosine of theta. Okay, well, with what we just learned, we're going to do inverses here. Secant's an inverse. So let's make these fractions. Anything divided by 1 is that same thing. So cosine of theta is the same as cosine theta divided by 1. So now I have a fraction, cosine theta over 1, cosine theta over 1. So now we're going to set up a proportion. And I'm going to take not OS over OR, but I'm going to do OR over OS. So before I go into that, let me come back here and flip this over. OR over OS is equal to hypotenuse over adjacent. So I'm just flipping it. And that is 1 over cosine theta. Okay, so it's a reciprocal. OR over S is just 1 over cosine theta. And likewise, OP over OQ is equal to hypotenuse over adjacent, which is 1 over the cosine of theta. Okay, so now we're going to set up a proportion, and we're going to take OR, the hypotenuse, over OS. So I'm going to set up a proportion now. I'm going to say OR over OS equals, so I took the hypotenuse, it equals OP over OQ. So there's our proportion set up. Hypotenuse over adjacent equals hypotenuse over adjacent of the smaller triangle. Now I'm going to substitute values in. So I just move this down here. Well, what is OR over OS? Well, it's 1 over cosine. But by definition, that is secant. So if I flip this over, it would be secant theta. Or 1 over cosine theta is secant theta. So I am going to say that this is going to yield secant theta, right? OR over S is 1 over cosine theta, and that's the inverse, and that's secant. So OR over OS is secant, and that equals OP over OQ. And what is OP over OQ? Well, it's right here. It's 1 over cosine theta. So if I put secant theta over 1, that's the inverse of 1 over cosine. Secant theta over 1 is equal to 1 over cosine theta. It's not the inverse of 1 over cosine theta, it's equal, so I just replaced it. So secant theta over 1 equals 1 over cosine theta, and therefore we had just proven that secant theta equals 1 over the cosine of theta. Okay, page 2 brings us to exercise 1. It says the definition of the secant function is offered below. Answer the questions to better understand the definition and the domain and range of this function. Be prepared to discuss your responses with others in your class. All right, so in this little box here, it says let theta be any real number. In the Cartesian plane, rotate the non-negative x-axis by theta degrees. Okay, so what they're telling you is to do this. Okay, I'm going to create an array, and let's make it red, and it's going to be originating at the origin, and there it is. There's the positive x-axis, is that red ray I just created. Okay, rotate the non-negative x-axis by theta degrees about the origin. So then we would rotate this around. Intersect the new ray with the unit circle to get a point x theta y theta. So anywhere I put this point where it intersects is x theta y theta. So they moved it up to the terminal ray here, and they called P x sub theta comma y sub theta. If x sub theta does not equal 0, okay, where does x sub theta equal 0? Right here at 90 degrees. That's the point 0, 1. And then down here at 270, this point is 0, negative 1. Okay, the x value or the cosine x theta cannot be 0. Intersect the new ray of the unit circle to get point x theta. If x sub theta does not equal 0, then the value of secant theta is 1 over x sub theta. Otherwise, secant theta is undefined. So secant theta is undefined here, and secant theta is undefined at 90 degrees. In terms of the cosine function, secant theta equals 1 over the cosine of theta. For cosine theta degrees not equal to 0. Okay, that can't be 0, it's undefined. A says, A says, what is the domain of the secant function? Okay, so as stated before, the domain of the secant function is all real numbers theta such that theta does not equal 90 plus 180k for all integers k. B says the domains of the secant and tangent functions are the same. Why? Okay, well, the reason for that is, I'll just do this. Secant, as we look here, secant theta equals 1 over the cosine of theta. Tangent of theta is sine theta divided by cosine of theta. And as you can see, cosine is in the denominator of both, and cosine can't be 0. Part C, what is the range of the secant function? How is the range related to the range of the cosine function? Okay, so range, what is range? Range is your y. Where can y be? Well, what is y? We're rotating around like so. So x sub theta comma y sub theta. So if I had 45 degrees, we're spinning around, we can rotate around this circle infinite times. So this is 1 degree, 90, 180, 270, 360, 450, or 360 plus 90 is 450, 540, 630, 720, and keep going, and keep going, and keep going, okay? So with respect to theta, it's boundless. The range of the secant function is negative infinity, because we could also rotate counterclockwise, negative infinity, all right? But when we get to -1, we can't have a value there because of the domain. So if we can't plug in, we can't get a -1. If we can't plug in 0 or 270, then -1 is not going to work. And that is also going to happen when we get from negative. We can also go from -1 to 1. That's okay. But then when we get to 1, then from 1 to infinity, we're going again. So in other words, it is the set of all reals minus -1 and 1. Okay, and what this really has to do with is not just the rotations, but what is the y value? The y value is going to be your radius, if you will. So if I have a unit circle of 1, my range is 1 to -1. But if I go larger, it'd be, so if I had a radius of 2, my range would be 2 to -2. So I can make a circle as big as I want, so that's why it's going to infinity. But on the unit circle, we cannot have 1 as our value for our y, because when y is 1, x is 0, and x is the denominator. Okay, I don't think I was really clear on my description there, so I brought this in. Since secant theta is 1 over cosine theta, okay, see, they're equal, and the cosine of theta is between -1 and 1 in the unit circle, okay, then we can see that either secant theta is greater than, so in other words, if this was a half, if cosine theta is a half, and you take its reciprocal, secant of the 1/2 would be 2. So when you take a fraction, 1 over a million, okay, or any really large number, then you take its reciprocal, you're at a million. So as you get closer and closer and closer to 0 for cosine of theta, you're getting closer and closer to infinity for secant. And that's why we can go from -infinity to infinity. So it says we can see that either secant theta is greater than or equal to 1, or it's less than or equal to -1. So therefore, the range of the secant function is -infinity to 1 union 1 to -infinity. So it can't be anything between -1 and 1. All right, part D says, is the secant function a periodic function? If so, what is the period? Okay, and yes, it is a period function because it repeats on every rotation of 360 degrees. So the period is 360. Okay, page 2 brings us to exercise 2, and it says, or is this page 3? I believe it is page 3. Okay, so in the diagram, it says the horizontal blue line is tangent to the unit circle at the point 0, 1. So that is right here. That is a tangent. And a line going through a circle, if this continued the other side, it would intersect over here. So that is our secant. But what's happened here is instead of measuring down and taking the horizontal or the vertical change for sine of theta, we're now drawing a triangle on the other side of secant, but we're calling that angle beta. So it says, A, how does the diagram compare to one given in the opening exercise? Well, it's just basically the same diagram with different angles and lengths marked. We can consider a rotation through beta degrees measured clockwise from the y-axis. So in other words, instead of going counterclockwise up here and theta being here, we're measuring all the way around going this way clockwise. And then we're taking the reference angle with respect to the y-axis. Okay, so measured clockwise from the y-axis instead of a rotation through theta degrees measured counterclockwise from the x-axis. So we're going this way from the y-axis. So basically starting here and going this way, that is angle beta with respect to the y-axis. Okay, it's essentially a reflection of the diagram from the opening exercise across the diagonal line y equals x. Okay, so that's all that is a reflection. B says, what is the relationship between beta and theta? Okay, so angle TOP, here's T. Angle TOP is beta, and angle SOP is theta, and SOP plus TOP equals TOS, and that's a 90-degree angle because it's a quarter of the circle. So we would say angles TOP and angle SOP are complements. So beta plus theta equals 90 degrees. Part C says, which segment in the figure has a length of sine theta? And which segment has a length cosine theta? Okay, in this one, you need to be careful with your thoughts. OU equals sine theta. Here is OU. If I were to draw a rectangle, OU would be the distance from here to here as well. And since theta's here, that'd be the point, whatever this value is, P. Okay, and that is equal to OU. So OU equals the sine of theta. And the cosine of theta, if we were talking about theta, we'd be talking about going over here. And since from O to P is cosine of theta, then UP is also the cosine of theta. Okay, so the cosine of theta is the same as the sine of beta. So remembering that, hopefully from prior lessons and from geometry last year, the cosine of one angle is equal to the sine of its complement. D says, which segment in the figure has a length of sine beta? Okay, so sine beta is right here, it's UP. So UP equals sine beta, and OU equals cosine beta. So notice what's happening here. OU equals sine theta, but OU equals cosine theta. UP equals cosine theta. UP equals sine beta. And there's a misprint, by the way. That's why I was pausing right there. I'm like, what is this? This is not quite what I was supposed to be saying. Which segment has a length of cosine beta? Well, OU is the cosine of beta. Okay, there's a misprint there. Now it makes sense because I know that UP is the cosine of theta and it's also the sine of beta. And OU is the sine of theta, but it's also the cosine of beta. It can't be the cosine of theta and the sine of theta at the same time unless it was a 45-degree angle. All right, part E, how can you write sine theta and cosine theta in terms of the trigonometric function of beta? Okay, so sine theta equals cosine of beta and cosine of theta equals sine of beta, which is what I was saying up here. So that's E. All right, page 4, example 2. Now we have this triangle drawn with respect to the angle beta in the circle, and it's triangle OPU, and then we have the triangle ORT that goes out to the point on the line that's tangent at the point 0, 1. I've redrawn them outside just so we can see an exploded diagram. And it says the horizontal blue line is tangent to the circle at 0, 1. So this horizontal blue line, line L, is a tangent, and the point of tangency is 0, 1 right there. If two angles are complements with the measure of beta and theta, as shown in the diagram, use similar triangles to show that secant of beta equals the sine of theta. So we've done this already kind of in the prior example. So I'm just going to bring in the solution and discuss it. Okay, so here we go. It says, consider the triangles OPU and ORT. Okay, by angle similarity, they're similar because this is beta here and this is beta. So if that is beta degrees and that's beta degrees, they're congruent. And then we have a 90-degree triangle. So we have angle similarity. So the two triangles are similar. Okay, so then we can set up a proportion. So we're going to say side OR, the big triangle, is to OP, the little triangle's hypotenuse. That is equal to TR, which is the tangent of beta, to UP, which is the cosine of theta. Following that? So we're going to say OP is to OR as TR or O, hang on, OR is to OP as TR is to UP. So big is to little. That's right here. So then OR over OP is secant of beta. Right here, secant of beta over 1. Because OP is right here, and that is 1. So this is the length 1 because it's a radius. Same with OT. OT is 1. All right, they're the same length. So if I say OR, that is the secant of the big triangle, or secant of beta. Okay, and OP is a radius of 1. That's why we have secant beta over 1. Following? That equals TR. TR is right here. Well, that's the tangent of beta. So we have tan beta over UP, and UP is right here, and that's the cosine of theta. So we have secant beta over 1 equals tan beta over cosine theta. Since cosine theta equals the sine of beta, and the sine of theta equals cosine of beta, we can rewrite this as such. We can say secant of beta, which is secant of beta over 1. They're still equal. Just got rid of that 1. And the tangent of beta is sine of beta over cosine of beta. And then we're putting that over this cosine. So this right here is just being substituted by this. Okay? Sine over cosine is tangent. Okay? But then if I take the reciprocal of that, it would be cosine of theta over sine theta. So notice what happened here. We take the reciprocal, cosine went up, sine came down. And since we did that, we're now talking about theta. And that's still over cosine of theta. So what happens now is the cosines cancel. So that's what they're not showing. So if I have cosine of theta, here, let me just do it without parentheses, less writing at this point. If I have the cosine of theta over the sine of theta, and I'm dividing it by cosine of theta, think of that as cosine theta over 1. You multiply by the reciprocal, which would be 1 over the cosine of theta. And these cancel, and we get 1 over sine of theta. And that's what they're trying to prove right here. Okay, so now part B says if two angles are complements with the measures beta and theta as shown in the diagram, use similar triangles to show that the tangent of beta equals 1 over the tangent of theta. Okay, so again, I'm just going to bring this in because we've done this. All right, so it says using triangles OPU again, and let me bring these down so we can see them. Okay, so here we go. I brought down my diagram that I'm going to use to explain. And so it says to use the two triangles that we've been using, triangle similarity, angle, angle. Then we take RT is to PU. Okay, which is right there, or UP. I don't like that right there. RT is to OT. All right. as, so if we go from R to T, we don't want that to say UP, we want it to say P and U. Our corresponding parts have to line up. And OT, I would say OU. There, that's better. I don't know why they put UP. They're going the wrong direction. Okay, so if I looked over here, RT is the last two in that order. PU are the last two in that order. That should not say UP, it should say PU. Okay, now with that being named, what is RT? RT is the tangent of beta, so there it is. OT is the radius 1, so that we put a tan beta over 1 equals, and PU is cos theta, which is right here, and OU is sine theta, which goes here. And since tan theta is sine theta over cosine theta, we can substitute tan beta over 1 as sine theta over cosine theta. So 1 over tan theta is the inverse of sine theta cosine, or cosine theta over sine. So therefore the tangent of beta equals 1 over tangent theta. Okay, page 5, discussion. Definitions of the cosecant and cotangent functions are offered below. Answer the questions to better understand the definitions and the domains and ranges of these functions. Be prepared to discuss your responses with others in your class. Okay, so now it says to let theta be any real number such that theta cannot equal multiples of 180. In the Cartesian plane, rotate the initial ray by theta degrees about the origin, intersect the resulting terminal ray with the unit circle to get the point x sub theta, y sub theta. The values of cosecant theta is 1 over y sub theta, and the value of cotangent theta is the inverse of tangent, which is x theta divided by y theta. Okay, so the secant, cosecant, and cotangent functions are often referred to as reciprocal functions. Why do you think these functions are so named? Well, because these functions are reciprocals of 3 main trig functions. Secant theta is 1 over cosine theta, cosecant theta is 1 over sine theta, and cotangent theta is 1 over tangent of theta. Why are the domains of these functions restricted? Well, in secant, cosine theta can't be 0 because we can't divide by 0, it's undefined. In the cosecant of theta, sine theta can't be 0. And in cotangent, tangent theta cannot be 0. And when is tan theta 0? When the cosine of theta is 0. So cotangent and secant cannot be defined when cosine theta is 0. Okay, so it says we restrict the domain to prevent division by 0, which I just said. We restrict the domain because the geometric shapes defining the functions must make sense based on the intersection of distinct parallel lines. That was from last lesson, lesson 6. Okay, so the domain of the cosecant and cotangent functions are the same. Why? Okay, so the sine function has a range from -1 to 1. So the cosecant function has a range from -infinity to -1 union 1 to positive infinity. The two ranges only intersect at -1 and 1. Okay, let me go back to the last page for a moment. I put the wrong answer down. The domains of the cosecant and cotangent functions are the same because both the cosecant and cotangent functions are equal to the rational expressions that have sine theta in the denominator. Okay, sorry about that. Okay, now on to page 6. Now it says, what is the range of the cosecant function? How is the range related to the range of the sine function? Okay, so the sine function has a range of -1 to 1. The cosecant function's range is -infinity to -1. And then jumping to 1 and going to positive infinity because of that inverse. As we're getting closer and closer to infinity, we're getting closer and closer to 0, right? The two ranges only intersect at -1 and 1. All right, now it says, what is the range of the cotangent function? How is this range related to the range of the tangent function? Okay, so the range of the cotangent function is a set of all real numbers. This is the same as the range of the tangent function. Okay, so now we have a table and it says, let theta be any real number in the Cartesian plane, rotate the initial ray by theta degrees around the origin, intersect the resulting terminal ray with the unit circle to get a point x sub theta, y sub theta. Then sine is y sub theta, cosine is x sub theta, tangent is y sub theta over x sub theta, secant is the inverse of cosine. Secant's the inverse of cosine. Sine and cosecant are inverses, and tangent and cotangent are inverses. Okay. For any theta such that theta is a real number, and for cosine, theta is a real number, and then we have restrictions on tangent. Tangents cannot be 90 or 270, and secants cannot be 90 or 270, and the cosecants can't be 0 or 180 degrees. Okay, same with cotangent. So then it has formulas. So tangent theta equals sine theta over cosine theta. Secant theta is 1 over cos theta. And cosecant theta is 1 over sine theta. And the cotangent is cosine theta over sine theta, which is the inverse of tangent. So what is the formula for sine theta? Okay. So sine theta, there are no formulas. It is just sine theta, right? And so since cosecant and sine are inverses and we have 1 over sine theta, well, sine theta would be what we'd have for this formula here, but they're not really asking that. It's not something to fill in. This is just to, this is a reference table to learn the concepts. It's everything all put together. The value, their restrictions on their domain, if there is one, and their formulas. All right, page 7 brings us to the end of lesson 7. Go to your problem set.